Hello, my name is Lauren Steimle, and today I will be talking to you about how we used optimization to help Georgia Tech respond to COVID-19. College campuses are often hotspots for infectious diseases like COVID-19. For instance, the New York Times found that there were over 700,000 cases of COVID-19 on college campuses in the US as of May 2021. Social distancing can be a useful intervention to slow the spread of these diseases on campus in classrooms, but this can also reduce classroom capacity to 15 to 30% for most classrooms. And so this leads to huge mismatches in the supply and demand for classroom space on campus. What the universities can do is that they can offer courses in different modes that vary in the amount of in-person instruction to adapt to this sudden space scarcity. Classes can be delivered in person, but with social distancing, remotely, or hybrid, which would be a mix of those two modalities, and perhaps ensuring that students need to attend a class in person, socially distanced at least once a week, for example. We helped Georgia Tech figure out what would happen if they only changed the course mode in order to address the sudden reduction in classroom capacity. For example, consider what would happen in this example if we delivered these 3 courses in these 3 classrooms for a particular time slot in the timetable. Under reduced capacity from social distancing, we would see that, for example, this math class with 10 students could no longer fit in this room with 4 seats, and therefore that class would need to be delivered in remote mode. Similarly, for this English class with 3 students, we see that it could be delivered in hybrid mode in this classroom with 2 seats. However, a key observation from our team was that this would open up classrooms, and therefore, if we reassign classrooms, we might be able to make better use of the space on campus. For example, if this math class is delivered remotely, that opens up this room where we can then deliver the Spanish class in a hybrid format with students alternating attendance, which in turn opens up room B, where we can then deliver this English class where all students would be able to attend in person with socially distanced or under social distancing. We considered this problem university-wide in what we call the classroom and course mode assignment problem. We formulated this as an integer program that works within the existing timetable, and our model uses binary variables to assign class sections to classrooms, and the assignment then dictates in turn the course modes. The assignment of a class section to its classroom dictates what mode that class will be delivered in. To do so, we look at the ratio of the enrollment of a particular class to the reduced capacity for the room it's assigned to, and that in turn dictates what mode that class will be delivered in. We consider in-person mode, hybrid split mode, meaning students attend at least once per week, in-person socially distanced, or hybrid touchpoint, meaning less than once per week, but at least S times throughout the semester, and remote otherwise. Working with the task force, we identified that there were multiple objectives that were important when solving this problem. We considered maximizing contact hours, which is the amount of in-person instruction hours delivered to students, maximizing mode preferences, since some classes, such as lab classes, had a strong preference to be delivered in person, and plan stability, meaning that we weren't completely overhauling the existing schedule or moving classes all the way across campus. And we used a hierarchical optimization approach to solve this multi-criteria optimization problem. We then applied our optimization model to the course sections and classrooms at Georgia Tech, and we compared the results of our optimization model to the original strategy considered, the no room reassignment strategy, in which only the course modes would change, but no rooms would be reassigned. Our model was able to provide much more in-person, socially distanced instruction. We saw that our model saw a 42% improvement in contact hours compared to the no room reassignment strategy, and that our model was able to satisfy 90% of mode preferences compared to only 37% under the no room reassignment strategy. We also demonstrated other managerial insights to the task force. In particular, we showed them that there was minimal benefit to this hybrid touchpoint mode, and so they ended up dropping that from consideration. Further, we showed that minimal sacrifices in mode preferences and contact hours can lead to huge reductions in relocation distance, and the task force showed that they were willing to accept those minimal sacrifices to achieve those large reductions in relocation distance. So in summary, we created a mathematical optimization model to help Georgia Tech respond to sudden space scarcity on campus. Our work was practical in the sense that it works within the university's existing timetable. It was multi-criteria, handling multiple competing priorities for the campus planners. Flexible, meaning that it always provided a feasible solution. The solutions just might vary in terms of how much remote instruction is used. And scalable, meaning that we were able to assign all graduate and undergraduate courses for Georgia Tech's fall 2020 semester. We used this model to obtain managerial insights, and this informed a collaborative and iterative decision-making process with the task force over the course of summer 2020. With that, I'd like to thank my co-authors and our funding support for this work.